Somewhere in the limestone hills of South Africa, inside a cave system called Sterkfontein, lies the most complete skeleton of an ancient human ancestor ever found anywhere on Earth. Not a partial jaw. Not a handful of scattered teeth. Nearly the entire body, skull, spine, arms, legs, hands, feet, belonging to a single individual who died roughly 3.5 million years ago. Scientists call her Littlefoot. And here's the part that should stop you. After more than 30 years of study, involving some of the most advanced fossil analysis techniques ever applied to a human ancestor, researchers still cannot agree on what species she actually belongs to. She doesn't have a settled name. Not because nobody has looked closely enough, quite the opposite. She has been examined, re-examined, digitally scanned down to fractions of a millimeter, and compared bone by bone against every plausible candidate species in the fossil record. And the deeper researchers look, the less she seems to fit into any of the boxes we've already built. In 2025, a new study went further than anyone before it, and reached a genuinely startling conclusion: Littlefoot may not belong to either of the two species she's been assigned to for the past decade. She may be something else entirely, a species that has never been formally identified, hiding in plain sight, inside one of the most studied fossils in the history of paleoanthropology. This is the story of how that happened, and why an almost complete skeleton can still leave us with an incomplete answer. The story of Littlefoot's discovery is almost as remarkable as the skeleton itself. The very first clue was tiny, just 4 small ankle bones, sitting in a box of animal fossils that had been collected from Sterkfontein decades earlier and largely overlooked. In 1994, paleoanthropologist Ronald Clark recognized what those 4 bones actually were: unmistakably part of a hominin foot, built for upright walking. That single realization sent Clark and his team back into the cave system itself, searching for wherever the rest of that individual might still be. They found her deep inside a chamber called the Silberberg Grotto, still embedded in solid, ancient rock, in a passage so narrow and unstable that freeing the skeleton couldn't be rushed under any circumstances. What followed was one of the most painstaking excavations in the history of paleoanthropology, roughly 20 years of careful, millimeter-by-millimeter work, chipping the surrounding rock away by hand, inside a cave environment where a single wrong strike could destroy irreplaceable bone that had survived for millions of years. It wasn't until 2017 that the world finally saw Littlefoot fully prepared and assembled, not a partial skeleton pieced together from scattered fragments across different sites, but a single, largely complete individual, found exactly where she had lain since the day she died. That level of completeness is almost unheard of in human evolution research. Most of what we know about our ancient ancestors comes from isolated teeth, jaw fragments, or a handful of bones. Littlefoot gave researchers something extraordinarily rare: an entire body, all at once, all from one individual. So what did this level of completeness actually reveal? For the first time, researchers could study an early hominin's entire body plan at once, rather than piecing together assumptions from isolated bones. And Littlefoot turned out to be a genuinely fascinating mix of traits. She stood somewhere between 1.2 and 1.3 meters tall, meaning if she stood beside an average modern adult today, she would come up to roughly hip height. Her hip bones were strikingly modern in structure, built to transmit force efficiently through the legs in exactly the way needed for sustained upright walking. That's a major piece of evidence for bipedalism, the defining trait that separates the hominin lineage from other apes. But her body wasn't built for walking alone. Her arms were notably long relative to her legs, and her hands were unusually large and powerful, the kind of anatomy you'd expect in an animal that spent real time gripping branches and climbing. Taken together, the skeleton paints a picture of an individual who moved comfortably between two very different worlds, walking upright across open ground when she needed to, and climbing confidently into trees when she needed to escape danger, forage, or rest. This dual capability isn't unique to Littlefoot among early hominins, but rarely has it been demonstrated this clearly, in a single skeleton, all at once. She represents a genuine transitional body plan, not fully ground-based like later humans, not fully arboreal like earlier apes, but a working combination of both, dated to somewhere around 3.67 million years ago, making her one of the oldest and most complete records of exactly this evolutionary in-between stage. Here's where the disagreement begins. For years, Littlefoot has been caught between two rival classifications, and the debate has never fully settled. Ronald Clark, the researcher who led her excavation, argued she belonged to a species called Australopithecus prometheus, a name that actually dates back to 1948, when it was first proposed based on other South African fossils. The name itself is a bit of a fossil in its own right. Prometheus, after the mythological figure who gave fire to humanity, was chosen partly because those early fossils were found near burnt bone and ash, leading researchers at the time to suspect this species may have controlled fire. We now know that idea doesn't hold up. There's no solid evidence that any Australopithecus species used fire deliberately, and that early ash was almost certainly unrelated, likely from natural wildfires rather than any hominin activity. So the species name Prometheus has been carrying a scientifically outdated assumption baked into it from the very beginning. Other researchers rejected the Prometheus label entirely, arguing instead that Littlefoot was simply another example of Australopithecus africanus, a species that had already been well documented at Sterkfontein and other South African sites since 1925, when it was first described by anatomist Raymond Dart. For nearly a decade after Littlefoot's public unveiling in 2017, this argument stayed unresolved. Was she Prometheus, or was she africanus? Both camps had genuine scientific reasoning behind their position. And crucially, both couldn't be right, which meant something in this classification puzzle was going to have to give. In 2025, a team led by researchers at the University of Cambridge and La Trobe University decided to settle the question using a level of precision that simply hadn't been possible before. Rather than relying purely on traditional visual comparison, the team created detailed digital scans of Littlefoot's skull, accurate down to fractions of a millimeter, and directly compared them against two other key specimens, MLD1, the original fossil that had defined the species Australopithecus prometheus back in 1948, and multiple confirmed examples of Australopithecus africanus. This was, in effect, a rigorous anatomical trial. If Littlefoot truly belonged to Prometheus, her skull should closely match MLD1's defining features. If she was actually africanus, she should align closely with those specimens instead. The team methodically worked through the comparison, cranial feature by cranial feature, letting the measurements speak for themselves rather than relying on impression or tradition. And the results didn't cleanly support either existing camp. When they compared Littlefoot directly against MLD1, the fossil her own species name was supposedly based on, they identified at least 5 separate anatomical differences significant enough to challenge that classification. 5 distinct points of divergence is not a minor technicality in this kind of study. It's the kind of gap that, under standard taxonomic practice, argues against grouping 2 fossils into the same species at all. Littlefoot, according to this new analysis, simply does not match the specimen her species name has been built around for years. But the study went a step further, and this is where it gets genuinely surprising. The team also compared MLD1, the fossil that defines the entire species Australopithecus prometheus, directly against confirmed Australopithecus africanus specimens. And they found something that undercuts the Prometheus classification at its very foundation. MLD1 itself doesn't meaningfully differ from africanus. In other words, the fossil that gave Prometheus its name may never have represented a genuinely distinct species in the first place. It may simply have been an unusual-looking africanus individual all along, well within the natural range of variation you'd expect to see across any single population. If that holds up under further scrutiny from the wider field, it means the species label Australopithecus prometheus doesn't have solid ground to stand on at all, independent of the Littlefoot question entirely. And that creates a strange, almost paradoxical situation for Littlefoot's classification. She clearly isn't a match for MLD1, the researchers found real, measurable anatomical differences there. But she also doesn't cleanly match the africanus specimens either. She's distinct from both established options, in a debate where one of those 2 options may not have been a valid species category to begin with. Which leaves exactly one remaining possibility on the table, and it's the one the research team ultimately pointed toward: Littlefoot may not belong to either named species at all. She may represent something that has simply never been given a name. As lead researcher Jesse Martin put it, the anatomical evidence points toward a conclusion that goes beyond simply ruling out two existing labels. It suggests Littlefoot represents a previously unidentified human relative entirely. That's a genuinely significant claim in paleoanthropology, and it's worth being precise about what it does and doesn't mean. It doesn't mean the team has formally named a brand new species. That process is far more involved, requiring broad consensus across the field, additional comparative fossils, and typically years of further peer review before a new species designation is widely accepted. What the 2025 study does establish, with real anatomical rigor, is that the two labels Littlefoot has worn for the better part of a decade, Australopithecus prometheus and Australopithecus africanus, both fail to adequately describe what her skeleton actually shows. She sits in a genuine taxonomic gap, distinct enough from both established categories that forcing her into either one misrepresents the evidence, but not yet formally recognized as anything else. It's an uncomfortable position for arguably the most complete and thoroughly studied hominin skeleton in the entire fossil record to be in, but it's also, in its own way, a remarkable demonstration of how seriously the field takes getting this right. Nobody involved in this research is rushing to slap a convenient label on her just to close the debate. The uncertainty itself is the honest, current state of the science, and Littlefoot remains exactly what she has been since 1994, one of the most important fossils ever found, still patiently waiting for the rest of the field to catch up to what her bones appear to already be telling us. And the story hasn't stopped there. In early 2026, a separate research team published a detailed virtual reconstruction of Littlefoot's face, a genuinely rare achievement, since only a small handful of Australopithecus fossils anywhere in the world preserve enough of the facial skeleton to attempt this kind of reconstruction at all. Using careful digital modeling, researchers were able to rebuild the key anatomical regions involved in vision, breathing, and feeding, giving the field a far more detailed picture of how Littlefoot's face was actually built and, by extension, how she likely experienced her environment day to day. This kind of reconstruction matters far beyond simple visualization. The structure of the eye sockets can inform researchers about field of vision and depth perception. The shape of the nasal cavity relates to respiration and potentially to the climate she was adapted to. The proportions of the jaw and surrounding bone connect directly to diet, what she was physically capable of chewing, and how that compares to the diets reconstructed for both Africanus and the broader Australopithecus record. Every one of these details adds another layer of evidence to the ongoing classification question, because subtle facial anatomy is exactly the kind of feature that can further separate, or further connect, Littlefoot from her nearest fossil relatives. The research team behind this reconstruction was careful to note that Littlefoot's face offers a genuinely rare reference point precisely because so few other fossils from this period preserve this much detail. Whatever her final species classification eventually turns out to be, this reconstruction ensures that classification will be built on some of the most complete anatomical evidence available anywhere in the human fossil record. It's worth stepping back and asking why any of this matters beyond a single fossil's paperwork. Getting classification right isn't just bureaucratic tidiness, it directly shapes how we understand the broader shape of human evolution. If Littlefoot genuinely represents a distinct, unnamed species, that adds yet another branch to an already crowded and complicated family tree during this period of South African prehistory, alongside the established Africanus population and whatever MLD1 ultimately turns out to represent. If the Prometheus classification collapses entirely, as this new analysis suggests it might, it also means researchers will need to revisit every other fossil that has been grouped under that name over the past several decades, since analyses and conclusions built on a flawed foundational specimen may need to be reconsidered. This is genuinely how paleoanthropology works, even though it can look messy from the outside. Fossils don't arrive with labels attached. Every species name applied to an ancient hominin is a scientific hypothesis, built from the anatomical evidence available at the time, and every hypothesis remains open to revision when better evidence or better methods come along. Digital 3D scanning, capable of measuring differences down to fractions of a millimeter, simply didn't exist when many of these classifications were first proposed decades ago. It's not a failure of the earlier researchers that their conclusions are now being revisited, it's exactly what responsible science is supposed to do as tools improve. Littlefoot's case is a genuinely rare opportunity to watch this entire process unfold in real time, around one of the most important fossils ever recovered. Here's a detail worth sitting with. If Littlefoot were standing beside you right now, she'd come up to roughly your hip. Small enough that you could look down and see the crown of her head. And yet this one individual, barely over a meter tall, dead for roughly 3.5 million years, has managed to challenge one of the foundational species classifications in all of South African paleoanthropology, simply by being preserved completely enough for modern science to finally look at her closely and honestly. That's the real significance of Littlefoot's story. It's not really about a single contested label. It's about what becomes possible when a fossil this complete survives long enough, and gets excavated carefully enough, for every generation of new technology to keep asking it new questions. 20 years of painstaking excavation. Decades of competing classification arguments. Digital scans accurate to fractions of a millimeter. A full facial reconstruction, arriving nearly 30 years after her first bones were even recognized. And after all of that, the honest answer science can currently offer is, we're still not entirely sure what she is, but we're now more certain than ever about what she isn't. Which detail changed how you think about this story the most? That the most complete hominin skeleton ever found still doesn't have an agreed species name, that the label, Prometheus, was partly built on a mistaken idea about fire, or that she stood barely hip height to you and still reshaped an entire field. Drop your answer below, and tell me where in the world you're watching this from. Subscribe for the next deep dive into the fossils still waiting for us to get their story right.